Hello everyone and welcome to the tutorial series presented by Elisa on the topic keyboard interfacing. Now today we'll be going to see how does a matrix keyboard work. Now first question arises into our mind is what is matrix keyboard made of? What matrix keyboard is made of push buttons. Now the electrical connection of push button is same as that of DIP switch except that the connection is temporarily when key is pressed. When the key is pressed, mechanical metal contact bounces momentarily. This condition is called as key bouncing, can be eliminated by a technique called key debouncing. Debouncing is any kind of hardware device or software that ensures that only a single signal will be acted upon for a single opening or closing of the contact. Now as you can see in figure A, one of the terminal of push button is given plus 5 volt VCC, which is also given to the microcontroller, and another terminal is grounded. So when there is voltage difference between two terminals of push button, there will be a current flow and we'll get logic 1 level. In figure B, you can see after switching from logic 1 to logic 0, there is momentarily bouncing of key for 20 milliseconds, and same from off to on condition. Now how to deal with key debouncing techniques. There are two techniques, hardware technique and software technique. In hardware technique, there are two sub techniques, that is regeneration of NAND gate and IC MAX 6816. But since these are costly techniques than software, we'll be rushing through these techniques and we'll focus more on software techniques. So as you can see, Q is acted as one of the input of R NAND gate, and output of R NAND gate is acting as one of the input of S NAND gate, and key is switching in between those two and providing a steady output. And MAX 6816 is the IC which bounces internally and provides a steady output. Now to the software techniques. There are three major parts in software debouncing technique: checking a key closure, debouncing the key, and encoding the key. Now when the key is open, we get logic level 1, and since the logic level is 1, the reading should be 0xFF. When the key is closed, the logic level is 0, so obviously the reading should be less than 0xFF. So to ensure key closure, there are two techniques. First, if the reading is less than 0xFF, that indicates a key closure, and the key debouncing technique. Now in key debouncing software technique, we'll wait for 20 milliseconds, we'll read the port again, and if the reading is still less than 0xFF, it definitely a key pressed condition. A third part is encoding the key, which we'll see later. Now, as far as keyboard interfacing is considered, this kind of problem statements often comes in picture. Here we have to write a program to recognize a key pressed in register bank from 0 to 7. Now let's see how to deal with such problems. There are two tricks, or rather hints, to deal with such problems: hardware and software. Now in hardware, the port which we'll be using as, or which we'll be dedicating to keys, should be set up as input port, and pull-up resistors should be enabled. Now what are pull-up resistors? There are two types basically, pull-up and pull-down resistor. In pull-up resistor, one of the terminal of key is connected to microcontroller, while other key is connected to plus 5 volt. In pull-down resistor, one of the key is connected to microcontroller and other key is grounded. So you can look them up on Google. And another technique is software, where we check the key for debouncing and encode the key. Now moving on, how to interface a matrix keyboard. Again, there are two types, matrix keyboard and array keyboard. You can look them up. In matrix keyboard, we can interface multiple keys with fewer bits or fewer lines, as you can see in the diagram. Here we are using lower 4 bits of microcontroller as rows, while upper 4 bits as columns, and we are forming 16 multiple push buttons to form a matrix keyboard. Now, how to write a program and also the encoding of key. There are fewer conditions or rather tricks to write the program. First one is plus 5 volt to all the columns by sending ones. Check each key in row for logic 1, as in open, ground one column at a time and check all the rows and find out which key has been pressed, and once the key is identified, it is encoded based on the position in the column. Now this is the final diagram or Proteus simulation rather, which we'll be needing to see to simulate the program. Now we'll move to the coding basics. This is lcd.h file which we have covered in our LCD interfacing tutorial. You can see these are few functions: write command, delay, LCD init, which will be needing to initialize the LCD. These are just commands 0x3f, 0x3f to initialize the LCD. We have written another function, putChar function, to put the character in the LCD to see which key has been pressed. Now to the main part, our keyboard function. Here we have written unsigned character check key function. In this function, we have taken a variable named k, and by giving 0xff, we are setting it as input. Now going down, first condition, as you have seen, to make the roll 0 low. So for making this to happen, we need to set port 0 to 0xfe, ensuring that the last bit is 0, and we are ANDing it with 0xf0 to see which column has been hit. So 4 conditions, 0xe0, d0, b0 and 70, making sure that all the 4 conditions, that is 1110, 1101, 1011 and 0111, are being taken into consideration. In second method, we are making row 1 low. For this to happen, we are making second bit low, that is 1101, which is 0xfd, and we are ANDing it with 0xf0 to check the column, and we are repeating this condition until we get the output. Now in our main part, again we are taking two variables k1 and k2 to check the debouncing condition. Now focusing on loop, firstly we are making all rows low by putting 0xf0, or rather setting 0xf0 to port 0, and we are waiting till we get any key press. After key has been pressed, we'll get some output at variable k1, which is written by k in our check key function. We'll wait for 20 milliseconds and we'll check k2 or key again to get the output to k2, and we'll check if k1 is exactly equal to k2. If the condition is fulfilled, then our key debouncing software technique has worked. We'll write the output at 0xcc level, that is 0xcc th position of LCD, and again we'll make all rows low by giving 0xf0 to port 0. Again we'll wait for key to press and we'll check the key debouncing condition. Now we'll run the code and make sure that there are no bugs, no warnings, no errors in our code. So run the code. Zero errors, zero warnings, we are good to go. Now to the simulation part. We have loaded our hex file in 80C51 microcontroller. Now we'll run the program. As you can see, all the connections are as per diagram. Port 0 has been assigned to 16 keys. Okay, so if we check first key, we'll get key press 0, then key pressed 1, 2, 3, 4 and so on until C, D, E and F. So this is about the simulation of keyboard on Proteus. So that's about it. You can contact us on walchan.elisa@gmail.com. For more videos, you can like us on facebook.com/wcselisa. Stay tuned. This is Elisa signing off.